Hey guys, I'm going to be coming online shortly. Today is going to be, I just updated Twitch. The description of today's stream is just a down day. It's going to be C++, course creation, but I'm working on slide decks. I've done too much of other stuff. I got to get back to that. It's been about 4 or 5 days, not including the weekend, since I've been working on completing that training course. So stick around if you want to watch. It's great. If it's like watching paint dry, then head on out. All right, guys. Yeah, cool. Okay, so bear with me. I just have to get my material up on my laptop, and it's just going to be one of those days today where it's working on slide deck stuff. Okay. Drive. The last 2 days has been Node.js, JavaScript, full stack web development. Mostly actually just bug fixes though. Yeah. Okay. Find flow of control. Okay, so where did I leave off on my slides? I think I'm doing like section 2, flow of control. So relationals, containers, conditionals. Wow, there's a lot. I may have to break up section 2 into multiple sections. So, relational. Yeah. Oh, here we go. Just on Google Drive, and I just found out how to. Yeah, cool. Control F. And finally, okay, so I'm going to work on the presenter notes here. So relational operators are easy to understand if you're familiar with the concept for blah, blah. Relational operators allow us to determine some elementary relationships between variables. For example, given two variables, x is equal to 5 plus y. No, that doesn't make sense. and y is equal to 10. What can we say about them? Well, we can say that they're not equal. Also, we can say that x is less than y, or that y is greater than x. And C++ relational operators allow us to say these types of things expressed in code. Relational operations are a Boolean logical expression. Relational operations more specifically, an expression that evaluates to a truth value that is either true or false. It's not too bad. For example, when speaking of equality, the two variables being related are either equal, true, or they are not equal. They're either equal, true, or not equal, false. So let's see here. So what do I actually say in the slide? Relational operators allow you to relate or compare two values that result in a truth value. Yeah, relational operators should be somewhat familiar from your high school algebra class. Some of the relational expressions we may use are x does equal y, x does not equal y. Yeah, it's okay. So let's look at the next slide. So relational operators. Here are the 6 relational operators. So the equal equals is an equal operator. Not equal, yeah. So the first operator is the equal operator. This is used to test whether or not two values are equal to each other. This operator returns true if both operands are equal. Otherwise, it will return false. Recall that the single equal sign in the assignment operator in C++. Recall that the single equal sign is the assignment operator. In C++, we use the double equal sign to test for equality. Yeah. The not equal operator is the opposite of, yeah, that's obvious. It returns true if the two operands are not equal, otherwise it returns false. It's kind of a bit dangling here, I think, because I talked about the single equal sign, and then we dive in as if our last statement was talking about the equal operator. So I might reword this. The not equal operator is the opposite of the equal operator. The less than operator returns true if the left-hand operand, just move my mic a bit here. True if the left-hand operand is less than the right-hand operand. Otherwise, it returns false. The greater than operator returns true. Okay, let me read this again. I'm kind of off. The less than operator returns true if the left-hand operand is less than the right-hand operand. Otherwise, it returns false. The greater than operator returns true if the left-hand operand is great, of course. Finally, we have the less than or equal to operator and the greater than or equal to operator. These operators will also include equality, exactly, between the left and right hand side. For example, 6 is less than or equal to 6 would return true, whereas 6 is less than 6 would return false. Yeah, that's fine. And then, yeah, good. So I've got a slide now for examples, because it's kind of getting too much talking, not enough action, right? So relational operator examples. So now let's look at some examples of relational expressions. The idea here is to know what these expressions will evaluate to, a Boolean or true. Yeah. The idea here is to know what these expressions will evaluate to. As a Boolean, in terms of a Boolean or truth value. And then eventually I'll just drop the term truth because that's more a mathematical term, whereas people in programming would be a lot more familiar with using the term Boolean. In the first example, we have does. Okay. In the first example, we have I think it just makes less sense because of where the comma was separating that train of thought. In the first example, we have, does W not equal Z? This is definitely true since 3 is not equal to -5. -5. Yep. In the second example, we have, is W equal to Z? This is false since 3 is not equal to -5. Perfect. In example 3, we have, is W less than Y? This is false since 3 is not less than 3. In example 4, we have, is W less than or equal to Y? This is true since both W and Y are 3 and therefore the same. In example 5, we have, is Z greater than X? This is false since -5 is not greater than 0. Finally, in example 6, yeah, I guess this strings along okay. We have W is greater than or equal to Y. This is true since 3 is equal to 3. Okay, good. That sounded okay. Now that we have covered some simple relational operator examples, let's focus on logical operators in the upcoming slides. When working with Boolean or truth values, there are 3 types of logical operators we would like to use. Let's consider 2 Boolean variables, X and Y. We would like to make I wonder if, it's almost like I'm going into the logical operators here. This may have to go into this slide. So logical operators are logical and, or not, right? The double ampersand, the double pipes or vertical bars, and the exclamation to flip. Okay, so let me go back to this stuff. Now we have covered some simple relational operators examples. Let's focus on the logical. And that's almost where I should break. Ooh. And that should almost, from there on, go into another slide, unless, because it almost, like, it's all straight up logical operators. I mean, that's all I talk about. So I might move this. Let me read through it first, though. When working with Boolean or truth values, there are 3 types of logical operators we would like to use. Let's consider 2 Boolean variables, X and Y. We would like to make statements against these 2 Boolean variables, such as, if X and Y are both true, then do something. This statement in your C++ code can be written using the logical AND operator, which is denote. Yeah, this has got to come out of here. We could also make the statement, if either X or Y are true, then do something. This state, yeah, see, it explains logical operators great, but I just have it in the wrong slide. The logical AND and the logical OR operators are binary operators, which means they use 2 operands, the left hand and the right hand operand. Finally, we could also make the statement, if not X, then do something. This statement would be written using the logical NOT operator, which is denoted using a single exclamation mark. The operator is a unary operator, which means it works on a single operand. Let's start looking at these logical operators. Yeah, yeah, that's not cool. And then this is logic. Okay, so I need a new slide because we talk about each individual logical operator. So I'll need to add a new slide. And it's just more of an informational slide. So I'm going to copy or duplicate one of my existing slides. So it's almost like this, but not. Actually, maybe the slides we were just on. I don't like that image. Darn it. And that image is completely wrong. But this slide is perfect for what I was just talking about. So I'm going to paste this. And I'm going to cut. Jeez, what's jumping around? So, Control X. I'm going to leave that bulleted list there for a second. So what do I need to say? Or what do I need to show more specifically? The image is pretty good because it's a truth table using logical operators. I know I chop off the not, but let's see if I can crop and move. That's pretty skewed. Yeah, I'm gonna leave it. It's skewed, but whatever. Okay, so when working with Boolean or truth values, there are 3 types. Yeah. So I'm just gonna look at some of my scribbly notes on my laptop. Just see how I want to talk about this. So one. Hey, string keys. It's kind of tough to say what's my main programming language. I started out in probably in '99 working on C, C++. Then I decided to go out contracting. So in the early 2000s, I did everything and anything. I did even Cold Fusion, if you remember that old language. I didn't do much of it, thank God, but a little bit. But mostly mainstream languages. But to be honest, I guess the most time would be C Sharp. But a close second would probably be JavaScript, like Fullstack, because that's the last 4 years, 5 years for me of what I've been doing mainly. C, C++, yeah, it's up there. Java's definitely up there. Worked for a big financial institution doing a lot of enterprise Java development for them. But a lot of .NET as well. But the cool thing is like once you learn a language, once you have the fundamentals, like I did this interview for a big company, and I really respect this company. I mean, like, it's Facebook, and I like how they do their interviews because it's irrelevant what what programming language you know. They don't care. They don't care. It's all about the fundamentals, right? Like what are the like how does a certain algorithm work? How do these data, like, create a data structure like a linked list, a doubly linked list? Understanding that, understanding algorithms like sorting algorithms, for example, or searching algorithms, like a selection sort, an insertion sort, a bubble sort. If you can kind of get those fundamentals down, knowing trees, knowing graphs, knowing how to traverse trees, knowing how to insert nodes into trees, especially sorted trees. So you know, do you put it on the top? Do you put it on the bottom and bubble it up? Knowing that stuff is really the most important thing. Yeah. But yeah, I jump around on languages quite a bit. To be honest, I'm doing this course in C++, not because it's my most my strongest tool in my belt. It's just because I don't know. It's just because I just want to do a training course in C++. I didn't feel like doing it in a more mainstream, a more modern current language that everybody's doing training courses in. So this training course is going to be C++, but focusing on game programming. So I'm going to try to, all the examples are going to try to slant towards game programming. Right now we're learning the basics, but the examples will be doing a lot of geometry and math, because as you get into game development, you kind of have to have those fundamentals. So it's what I'm trying to focus on. Logical OR. I guess I should actually spell it out because I'm defining the logical AND, the logical OR, and the logical NOT. Which is a bang. Sweet. So I guess I can turf these guys. I hate doing slide decks. This is just not fun for me. But it's a necessary evil. I've seen some courses out there where there's almost no slides, if at all. And it's more off the cuff. And I can do that, but I don't know. Comes across a little more professional if you do slides as well. So I'm going to actually align these guys. And I think that's, yeah, it equals the distribution. The only thing is this guy acts as, I kind of have to clean these up. This guy acts as actually a bulleted list, whereas these guys aren't. You can see the spacing's a little bit different. Okay, so C++ contains 3 logical operators. The logical AND operator, OR operator, and the logical NOT. Okay, let's see how this strings along. And I already read this out, but I just want to make sure it kind of works. So C++ contains 3 logical operators, the AND, the OR, the NOT. When working with Boolean or truth values, there are 3 types of logical operators we would see. Let's consider 2 Boolean variables, x and y. We would like to make statements against these 2 Boolean variables such that if x and y, blah, 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 logical and the logical OR are binary. Yep. Finally, we would also we could also make a statement that, yeah, okay. I almost should put like binary operator and then sub, like a sub list for the OR and the NOT, and then unary for the NOT. I might do that. Let's do that. As much as I hate, I'm not good at slides. I was never a PowerPoint guy. I mean, I'm okay. I'm just like everybody else, right? Like most people who are computer savvy, everything just comes to you. Like you can pick up anything and just do it. You may not be the best at it, but you know. So I'm going to go A. And of course it automatically. I hate this. I'd like it just to say, don't assume I mean. And I mean like you can where the heck is it? Okay, maybe I can undo it. But as soon as I undo it, it removes the A. It's like, I bet you there's a special way of doing it. It's just like in Excel. If you hit Alt plus Enter at the same time, you can do a line break in a cell. And it's almost like if I hit Alt and space, will it? No, of course not. If I put the space in, it automatically interprets that as a... okay, well, let's do it. And then I'll do a new line. And then, yeah, I guess I shouldn't try to overthink it. I should just work with how these slides work. Okay, so let's unbold this guy, but then I don't want to bold the B. It's just so hard to see. Okay. So if I unbold it, well, but see, the B is still bold. Okay, unbold. Bloody hell. So I'll just call this binary logical operators. I don't know if that's the best way to present this, but I'll leave it for now. I just want people to actually see the slide, and it has almost enough info. Jeez, I can't even. Can I just move this, please? Please? Oh, God. Oh, I hate slides, man. I hate doing this. I've been streaming. I've been avoiding doing this for probably almost a week now. I might shrink this because it's a little bit too in your face. That'll do. And I'm actually going to copy paste. Yeah, that's okay. Binary operator. Da-da. So I'm going to line these guys to the left. Doesn't really look good to me. Thanks for not aligning to the left, by the way. Oh my God. I think I'm going to have to rethink how I do these lists. It's just wrong, right? That doesn't look good. Like I'm clearly just, yeah. Maybe I can shrink that. Yeah, I'm gonna totally redo how I do lists. Yeah. Yeah, whatever. I'll leave it like that. Okay, so let's just see. So yeah. In the lot, let's start looking at. Okay, good. I think we're good. So the logical AND operator. This slide will look at the logical AND, and the AND operator works on two operands: the left operand and the right hand operand, to create a binary or compound statement. Yeah, that's a compound doesn't. I don't like that. Not sure if the right term to use is expression or statement. I'll have to look at that. The logical AND statement is true if and only if both sides of the statement are true, as shown in the example and truth table. As shown in the truth table image on this slide. If either operand in the statement are false, then the statement will return a false result. Return a false result. Okay. The truth table on this slide shows all possible results of a logical AND statement. As you can see, the only time the logical AND evaluates to true is when both A and B are true. Should I talk about the examples on here? Of course I should, right? So, examples using logical AND. So, let's type that out. In the examples on this slide, the first example defines two variables x and y, which are both true to bool yeah, that might help. Okay, so the first example defines two Boolean variables x and y, which are both true. Then we output to the console the binary logical AND operation using both x and y, which results in a true result. Which results in a true result? Yeah, whatever. As you can see in the truth table, this is the only time logical and operation will return a true result. I'll leave it like that. I might have to read it out loud again. And in the second part of this example, we set x to false, and again we perform the logical and operation against, should I say against, using x and y. This time the result is false, since one of the operands in the binary expression is false. Yeah, okay. Let's look at another logical operator, the logical OR operator, in the next slide. Yeah, you know, whatever. If you guys think that kind of sounds bad, just let me know. I mean, I'm not exactly the best wordsmith out there. Normally I do it and then I go back and I see how it can be improved. Okay, so the logical OR. A logical OR. In this slide, we look at the logical OR operator. The OR operator, just like the AND operator, works on two operands, the left and the right hand operand, to create a binary. The logical OR statement is true if and only if one or more of the operands are true. Therefore, if either the left hand or the right hand operand is true, then the statement is true. The statement is also true if both operands are true. The truth table on this slide shows all the possible results of a logical OR statement. As you can see, the only time the logical OR evaluates to false is when both A and B are false. And then I may just pilfer. Google Slides is great, but like it kind of jumps around. Sometimes it doesn't know where I'm trying to highlight and select. Like that, I clicked down here and it jumped up to the top. Like it's a bit hokey, but that's what you get. I mean, like you're trying to represent what you're used to in a browser using JavaScript and crazy hokey JavaScript magic. Okay, in the examples on this slide, the first example defines two Boolean. Clearly, I am a monkey. I just copy these slides. Like I create slides and then I just reuse them, obviously for consistency and for, you know, not laziness, just efficiency. Yeah, and so that's why those were ints, I think. It's because they were probably from another example somewhere. In the examples on this slide, the first example defines two Boolean variables, x and y, which are true and false respectively. I think that makes sense, right? Respectively, like in order of. Then we output to the console the binary logical OR operation using both X and Y, which results in a true result. As you can see in the truth table, this is the only, no. As you can see in the truth table, a logical OR operation will return a true result when either operand is true. In the second example, we set X to false. And again, we perform the logical OR operation using X and Y. This time it results in false since both of the operands in the binary expression are false. Is false. Was that one also ridiculous? This time the result just jumps. This time the result is false since one of the operands in the binary expression. Okay, that's fine. Cool. Let's look at another logical operator, the logical it just jumped. Yeah, okay, thanks. The logical not operator on the next slide. Cool. Okay, again, I'm going to correct that to a bool, and you can be a bool. Wouldn't you like to be a bool too? Logical not. Looking at the logical not operator, we can see that the logical not operator simply negates or flips a result of a truth value. So if X is true, then not X is false. If Y is false, then not Y is true. Yeah. Simply there's not a whole lot to say. I should say this is a unary operator. The logical not operator is a unary operator since it works on only a single operand, as shown in the truth table on this slide. Looking at the examples on this slide, looking at the example code on this slide, we can see we can infer the following. We can infer the following. Fuck, it's horrible. Let's see. Define explore. I want a thesaurus. I don't want to. Okay, define, I guess. Define though. Okay, synonyms. Good. Okay, deduce, conclude. Yeah, conclude is better than infer. Interpret. Understand. Understand is probably cleaner, right? It's kind of like, what's that rule of thumb? It's like for people who write articles as a writer, your target audience should always be someone at a grade 8 level of comprehension. So in other words, dummy it down for the lowest common denominator. And I'm I'm not trying to insult. I'm just, even for me, you know, like you just kind of make the simplest words you can, right? Looking at the example code on this slide, we can understand sucks though. We can deduce the following. We can, maybe deduce is good. I think understand just sounds ridiculous. So if X is true, then yeah, given X, given the variable X. So yeah, we should speak in less in mathematical terms. Like that's kind of a mathematical statement and more in a coding statement. So let's just say given the Boolean variable X, given the Boolean variable X, which is equal to true, then not X results in false. Given the I can just simply copy that, I think. Given the Boolean variable Y, which is false, then not Y results in true. Bottom line is the logical not operator simply flips a Boolean value. That's right. It's the Boolean's value. Okay, so let's move on to some examples. Logical operator example. Looking at the examples on this slide, evaluating a logical expression is not too hard. Once you grasp the truth table examples in the previous three slides, evaluating the results of any logical expression should become second nature. However, it will take some practice, which we will do in demos and problems. Whatever. So let's look through the examples on this slide to understand the logical expressions. Not only is it important to evaluate a logical expression, it's also important to be able to create a logical expression within a statement in C++. So now let's look at the examples on this slide. Example 1, here we have W logical and X. This expression will evaluate to false, since the only time the result is true in a logical AND is when both operands are true. In this case, W is false. In this case, the W is false. Boolean variable is false. Therefore, the statement results in a false. Example 2. This example is similar to the first example. However, we add the logical not operator to the W variable. It is important to note that the unary logical operator has precedence, good, I'm glad I put that in, over the logical and or and logical. The logical and or the has, it's kind of like you don't want to add, like it's like, has precedence over both the logical and as well as the logical OR. It got a little more wordy, but I didn't want to throw in an or and in here. Therefore, the false becomes a true on the left-hand side of the expression, and the result of the logical and is true. Cool. In example 3, W or Y. This evaluates to true because in a logical OR, as long as one operand is true, the whole expression will be true as well. Yep. W is false, Y is true. Perfect. Example 4, W, which is false, or not Y, which is true. It should be easy to see that the expression evaluates to false, since the logical not applied to the variable Y will flip it from a true to a false. Therefore, both operands are false, and our expression becomes false too. And our both operands are false, and our logical OR expression and there for our logical OR expression becomes false. Okay, good. And then finally, here we have here we simply apply the unary logical not to our variable x, which is true. This expression will flip our false to a true. This will flip this expression will flip the false to a true. I should say this though, it is important to note that the value of the variable x does not change. Only the result of the logical expression. It's important to note that the value of the variable x does not change to false. Only the result of the logical expression. Yeah, I know where I'm going, but I don't know if I like that. I'll leave it for now. Okay. So we need to add, so I did some demos and I want to put the demos in here. I don't want to jump to flow of control like conditionals and looping yet. So let's open up Visual Studio. Excuse me. I've got some C# going on, Mongo game. I want to stream that. I'm excited to do Mongo game. I got an old game that I really want to get on top of and stream that. Okay, so these are section 2, while loop, vector demo, variable scope, simple functions, ranged loop, putting it all together. So maybe I will do some code. Vector. I don't think I did any. Oh, here we go. That shouldn't be named problem 2. So let's we'll open up problem 2 in Visual Studio. I also want to look at the other problems just to see if they're logical operator problems. Oh, perfect. We got our relational operators, so we need this as well. All of this code is on GitHub, by the way, if anyone's interested. The link to that is on my Twitch front page. Where was I? Here we go. Problem 4 is all about compounds. Okay, good. We've got relational mixed in with logical. So that really covers the extent of what I need to demo. Cool. Problem 4. And so what do we got open? 3, 2, and 4. Do I have any more? Did I look at 5? I don't think so. Loops. So that's flow control stuff. So I'll cover that in the next slides. Okay, cool. So I've got 3 problems, but these were problems I devised in slides. So I'll go back to the slides. Which one's my slides? Jeez, everything's frozen. Too many Visual Studios running and streaming. Come on. Come on. There we go. Oh, the other browser was on my other screen. Okay, cool. Cool. Okay, so these are problems. So I need to go back to the slide. I may have actually created problem slides. Demo. Yeah, that's horribly small. Demo. Holy demo crazy. I thought I shrunk this code. I just simply truncated it. That's okay. It's a demo that we go over anyway. Okay, so problems, here we go. So that should not be problem 2, but it is. It's problem 3, problem 4. So let's look through these guys. So problem 2. Is that right? So problem 2 is problem 5. At the very least, I should probably do that. Just to confirm that looks right. So these are the solutions. So this is problem 2. Good. Problem 3. Problem 3. A is greater than C, D. Oh, where did I come up with C is not D? I better add that. I better go back. Let me just make sure I didn't bork all these here. Yeah. 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 Oh, I'm missing. I'm just getting confused where I'm at here. So that's right. And that is right. And that is right. And that is right. Okay. So problem 2 is golden. Problem 3. Yeah, I should probably. Oh, okay. So we did relational, we did logical. I need to add more slides about compounding it all together, putting it all together. And all we did was worked with Boolean values as well in those slides, which is good to get your mindset into how the expressions work, but we also need to work against realistic values as well. So I'm going to have to go back to that and add more slides. Okay, so anyway, what am I doing here? Looks good. Looks good. That does not exist. So that's what I found. So now I got a slide. I really should have put this in a bulleted list and everything would fall. Going forward, for now, I'm just gonna, what am I thinking? So I'm gonna copy that because I'm gonna paste it elsewhere. C is not equal to D. I may actually just add him. Oops. I'll just make him at the end and I'll move it down in code. Yeah, my slides started off nice, but then I did things my own stupid way, and now they don't look great. So more cleanup on those. So is it Alt Shift down? No, what was the keyword? Control Shift down? It's different on my Mac. I mostly use Mac, but I'm using Windows just due to my streaming. It's easier to stream Windows for people than it is. Oh, so I changed that one. This should really be what? B is not equal to false. Okay. I want to function shift down. Nope. And nope. There we go. Okay. So it's Control Alt Shift and up and down key to move a line of code. Or if I highlight a whole bunch. And that's from ReSharper, I believe. I don't think that's Visual Studio built in. Okay, good. So that's problem 3, problem 3, problem 2. Problem 1 is definitely going to move. Problem 3, 2, and this I guess is 4. So let's have a peek at problem 4. So A is greater than, let's first check. So A is 5.5 as a float, true for B, C is 9, and D is a char 9. Good. A is greater than or equal to C, or D is equal to D. Perfect. B and B, or D not D. Perfect. That one looks good. D9, la da da. We're using literals, great. A5, 5, good. And then the final one is a bit messy, so always work inside and out. So inside, that looks right. That looks right. That looks right. Flip, flip. Yeah, it's crazy, but it's good. Cool, cool. But that is problem 4. Okay. I'm going to move you to here. And I am going to put in a blank slide. New slide. The following cool. Okay. So actually I'm going to rename these guys. So this is going to be 1. This is going to be 2. And this will be 3. So I hate doing this because Visual Studio likes to, yeah, well, we'll do our best. I've already named these projects and I've already pushed them to GitHub, but that's life. Just expand, man. Okay. Okay, so this is going to be problem 1. We'll save everything. We will close solution. We will so we know problem 2 is going to become problem 1. So who's got that open? I closed you. You shouldn't be holding a handle, but I'll close this down. And I'm going to close these other Visual Studios down. They're just causing me grief. Mongo game. Sure. Try again. Why are you giving me grief? Yeah, that's not it. That is not it. The only other thing I can think of is if I'm in command window, but I'm not. Okay. Let's cancel that. Oh, gee. Okay. Why? Okay. Whatever the handle was, I don't know, but it's gone. So life is good. But we need to reopen this solution now and link that project because it was renamed. Let's give it a run, make sure everything's okay before I commit it to Git. Looks good. We're done with 1. 3 becomes 2. So where is 3? 4, 3, close. Let's see if I can rename it. We'll come back to you then. Oh, I should have done the Visual Studio stuff. I'll have to do that next. And there'll be still binaries in the debug folders that will be named with problem 3, but I've got a git ignore, which ignores like my binary files and my debug folders and stuff. So when I check this stuff into GitHub, all that gross mess isn't there. Okay, let me try this again. Good. Okay, problem 2. Just got to do some linking and some renaming in Visual Studio. So problem 2 is named. I just want to look at the properties. Not property manager, properties. I think it's F4. F4. Why isn't it actually showing? I thought, it is. Where's the Windows again? Other Windows, properties. Alt-Enter. Alt-Enter. And I'll pin that. Good. So problem 2, it's named OK. We'll just remove this and we'll include the new one. What the heck? I just want to get to the folder, man. It's like it should normally like whatever. Repo CPP training section 2, and I'm actually going to copy this path because if I have to keep traversing, I'm not going to be happy. So what I think we're on 2. God. Let's try this. Problem 2. So we just have to change the naming in here. I think we're good. So let's go ahead and run this. And we should get 2 in there, which is built today. Awesome. And it runs. Life is good. So we're done with problem 2. And then finally, problem 4 becomes 3. I should have done the renaming. That's okay. Okay. Okay, 3. Brilliant. Probably going to stream actually pretty long today. I really got to get this stuff done. Probably take a break in an hour or so and grab a bite to eat and start streaming again. this. Go away. Alt enter for properties. Okay, so 4 becomes 3. Was debating whether or not to do this course. Oh, I hope I was debating whether or not to do this on a Mac using like Eclipse or even Xcode for the IDE. But still, to this day, a majority of development is really done in Visual Studio as far as C, C++ is concerned. And especially for people learning, like it'll probably be on a Windows machine, and Visual Studio is free. The community edition is completely free. So people who want to learn C++ game programming can get very far on a Windows machine running Visual Studio. I was thinking of doing this course where the demos I would either do the demos a couple of times and you could watch the video where it's done on a Mac running a different IDE and on Windows running Visual Studio, but that's just too much overhead. I guess I could use like MinGW or Clang, which is just a compiler via the command line. And it's a similar compiler. Like this is Visual Studio compiles C++ using like MSVC compiler, their own compiler. That's fine. But I'm just trying to remember what Xcode uses. I think it's like GNU, like the GPP compiler, GNU compiler. I'm not sure what code blocks and some of the other IDEs use for a compiler, but you know, I could just do the code in Notepad or any text editor and compile it via the command line. Whatever. Anyway. Okay, so let's build this. Build succeeded. Did it? Did it? Let's just run it. Yeah, it runs okay. So problem 3 is complete. And yeah, it looks good. Okay, cool. So 1, 2, and 3 are done. They're in the right order. So this is a pretty easy group of problems. It just uses bools. This, however, problem 2 and 3 get more complex because the slides mostly talked about working with Boolean values. So I should go back to the slide deck and okay. So relational operator example. See, that's not bad. W is 3, 0, 3, and minus. Yeah. Yeah. So the logical operators. Now we need to learn about the logical operators combining with relational. Okay. So this is where it gets a little hairy. Do I want to... I'm going to look at some of my scribbles on my computer. I just want to see... Let's see. How do I want to handle this? Conditionals, reference pointers. So what did I do? Here's my examples. Okay. Okay, so what do I want to do? So let's talk about combining blah, blah, blah. Let me just see. Not that you need to hear desktop audio, but it says default. Hopefully you can hear desktop audio. Not that there's anything to hear. Okay, so I'm going to copy that flow of control slide. And let's talk about combining. Combining logical operators and that'll do for now. Okay, so far we've touched on common. Let's see here. So far we've touched upon, I know this is talking about looping and stuff, but I guess we can say something along the lines of we can just say something along the lines of the real power. That sounds stupid. I'm going to leave it though, and then I'll change it. I just need to get some thoughts out onto paper. So the real power is when we combine both relational operators and logical operators into statements. This allows us to create a flow of kind of defining a term that, oh shit, I'm typing this in copy. Wait a minute. Okay, and I better undo what I did here. Oh shoot. It undoes. It should know the history on a slide-by-slide basis. Stupid. Okay. Okay, so the real power is when we combine both relational and logical operators into more complex statement. This allows us to create a flow of control in our programs that can handle this allows us to create a flow of control in our programs that can handle any that's so dorky. It's just, yeah, the real power, blah. This allows us to create a flow of control in our programs that can handle any behavior we want to exhibit. It's crappy. I get it. Exhibit. No, that'll go. By combining both relational and logical operators, we can, for example, we can, for example, we can, for example, return a truth value in the following expression. I may have to change the slide to include a bit of example, because if I'm talking about an example, it should be on the slide too. So let's say given a player's hit points, given a player's hit points, no. Let's say a player in a role-playing game has 10 hit points, and a goblin has 5 hit points. This is kind of a shitty example, but I'm just trying to get some thoughts out here. So let's say a player in a role-playing game has 10 hit points and a goblin has 5 hit points. We can combine these two statements to see if a game over condition has occurred. For so let me copy some code. Copy that. I'm going to actually paste this on here. We'll drop that in here. So let's define int is 10. And so I want to do this. See out player hit points less than or equal to 0, or goblin hit points I'm going to just call it HP just for brevity, and so I don't have to worry about the formatting as much. So let's see. So see out player hit points is less than or equal to 0, or goblin hit points is less than or equal to 0. If true, then game over. So by combining both relational and logical operators, we can examine the truth value in the following expression. Let's say a player in a role-playing game has 10 hit points and a goblin has 5 hit points. We can combine these two variables into into a statement, into an expression, to see if a game over condition has occurred. In the example code on this slide, we combine the two relational operators. We combine the relational operators, operator less than or equal to with the logical or operator to result in a Boolean to yeah, I'm gonna come back to that in a moment. Okay. Yada yada yada. I hate this. I do. I hate this. I just hate doing slides, coming up with stuff to say. Why am I teaching? I don't know. By combining blah, let's say a player in a role-playing game has 10 input. As you can see, this complex expression player HP is less than or equal to 0, or, and I'll read that out loud, goblin H is less than or equal to 0. As you can see in this complex expression, player HP is less than or equal to 0, or goblin XP the outcome of this expression will always be truth or Boolean result. Using the Boolean result, we can control the flow of our program using expressions like this one to trigger parts of our program using conditional statements, which we will cover shortly. First, let's work with combining relational and logical operators. First, let's work with First, let's work with combining. So I am going to, yeah, this really needs to be fixed, but at least it gives us now. What does WOT mean? Like what? What am I doing? Nin Gamer? Just doing slides, buddy. Just doing slides for C++ training course. So nothing too exciting. Yeah, what did I do that for? I guess I can move you down here. So combining logical and yep. Combining logical and relational operators. Teach lambdas. Yeah, no, sorry, buddy. This is it's all about me. It's all about me. Okay. So let's combine these. So I guess we need to kind of need to do examples that are similar to this problem. So we can just define a few variables and combine some stuff. Where are my demos? I got so many freaking demos. Where am I going? Nin Gamer. Yeah, man, I wish I was doing something else. I just got to get this. Like the first couple of few sections of this course, it's all basic C++ programming. And then we get into the funner stuff, create some classes, do some inheritance, love and life. We got to follow. Who's that? Who's that? David Tay Dude. David the Dude. Thanks, David the Dude, for the follow. I do appreciate it. I am streaming on YouTube as well as Live EDU, which I created an account for. I don't even know how Live EDU works, but I'm streaming on there too. And I tried to stream on Periscope, but it's kind of hokey. So, yeah. So let's see. Okay, so combining logical and relational operators. So let's just define some stuff. So int w is 10. I guess w is 10. X is I just don't know. Do I want to get crazy? Let's see. We'll leave it bool and we'll throw in a float, I guess. I'm just going with the float here. I'm just going with the float. Okay, so let's combine this stuff and see. And I might change up these examples. I'm really, this is completely ad hoc. Yeah. But we have to combine a logical and a relational operator. So let's do a simple one. X and W is greater than Y. So true and 10 is greater than 5.5f. And that results in true. So C out not X and W is greater than less than 50. So I'll throw in some literals. So flip the true and 10 is less than 50 is equal to false. So what else can I do? Do I want to get, okay, let's forget about the bool on the left-hand side. Let's work with our y is equal to 10 or y is not equal to 0. I don't know if I like that. Well, you know what? Sure. Okay. So what's y? 5? Or let's make it really easy. Turd Ferguson. So that's obviously true because it's true in both cases. So maybe I will copy this. It's true. Well, yeah, okay, I'll leave it. I was hoping to put in some game specific examples, but this is okay. I'm going to probably finish this slide and then I'm going to take a break for 20 minutes. I'm starving. 12:39. I haven't been streaming that long. Since 10:30, I guess. 2 hours now. I gotta make my streaming environment more user-friendly. I'm in my basement. It's nice though. It's like a walkout. So I got big windows in front of me, but it is chillier down here than it is upstairs. And I've got one of those oil-filled heaters, but it doesn't really radiate the heat. You kind of have to almost put your feet right on the heater to get warm. But I do have one of those ceramic heaters. I might plug that sucker in. We'll see. Maybe I'll bring a blanket. Get cozy. Okay, so what else do we got? So given that, what else can we do? So let's logical not some stuff. Not X or not or let's do that. Not x not equal to x. Yeah, it's goofy. It's something you would never do, but it's all about hey, Sammy 99999. I remember you. I do, I do. Yeah, so it's getting hokey, but that's cool. And so what are some of the relational operators I haven't covered? So equality. I've got not equals twice. I'm just using not equals like crazy, so I'll do that. And yeah, man, that's cool. Self-learning. See, yeah, well, you know what? I'm going slow as molasses today because it's really the rule of thumb that you hear when it comes to teaching is it's like for every 1 hour of content, it's 10 hours of prep. So you're in the 10-hour zone. So if you were taking a C++ training course right now, yeah, what we've learned in the last 2 hours is really about 1/5 of what if I was actually training you would get as a result. So since I've been going for 2 hours, so yeah, about a fifth. You get it. Okay, what am I doing? I just want to get this done, and then I'm gonna break because I'm gonna go and take a break. Okay, so if not x is equal to y, well, we know that's false, right? Because we know not true is equal to true. That's false. And the and, we remember in our and truth table, I'll make it kind of easy. And y is equal to 5.5f. But we know that side is going to be true. However, we've got a logical and. So in the true statement, both sides of a logical and have to be true. Seeing what I forgot. I guess I can put a less than, like a greater than or a less than equal to in there. So I haven't done that. 10 is less than or equal to W, or y is greater than or equal to 5.05. Well, in this case, 10 So we know that is true on all accounts. And I'm running out of room, but I guess I get to talk about them. You got it, bro. False and true is false. Logical operators, combining logical and relational. Okay, so let's just work through this. So looking at the examples on this slide, evaluating. Okay, I guess I have to change this up because it's the same verbiage I've used. Let's work through the examples on this slide. Here we are given some variables we will use in the example statements. I really should be using the term expressions. We're not really making it a statement. We're actually creating an expression that we would use in a statement. So I kind of have to change. I got to go through this stuff and kind of reword things. Let's work through the examples. Here we are given some variables we will use in the example expressions. So W is 10, X is true, and Y is 5.0. The first, I might reword compound, but yeah, the first combined expression is X and W is greater than Y. This results in a true since both the left hand side expression and the right hand side expression are both true. So now let's drill into that. So let's drill into that. The left hand side simply evaluates to true as X is true, and the right hand side evaluates to true since W is greater than Y. Since W, which is 10, is greater than Y, which is 5 as a float. Note that comparing numeric values will implicitly cast the float to compare to the int. I might reword that, and yeah, I'm not sure if I like that. Okay. Okay, so let's look at the examples on the slide. I should say example 1. First combined expression is blah, blah, blah. Yeah. So let's go example 2. Here we have a logical and binary operator where the left hand side is a logical not unary operator applied to our x variable. I know this is not correct grammar, but whatever. It's whatever I need to cue me to say what I need to say. Okay, so our left-hand side is a logical not unary operator applied to our x variable, and the right-hand side, and I should almost shortcut right-hand side, RHS, LHS is, and the right-hand side is relational expression a relational binary expression where its right-hand side is the variable w and its left-hand side is 50. Now I better talk about the relational operator. So in the right-hand side is a relational binary expression using the less than relational operator, where its right-hand side is the variable w and its left-hand side is 50. Okay, hopefully, let me just read that out loud again now that I've puked all that out. So here we have a logical and binary operator. Here we have a logical and operator. I'm going to drop binary because it just gets confusing. We already learned that it's a binary operator in that it has a left and a right-hand side, right? 2, binary 2. Where the left-hand side is a logical not unary operator applied to our x variable. I'll leave in the explicitness of saying unary operator, just so that people can see it's you know, it's not binary. I mean, you know, I think I want to drill that in. The logical not unary operator applied to our x variable, and the right-hand side is a relational binary expression. I might leave binary in this case, using the less than operator, using the less than relational operator, where its right-hand side, no, what am I doing? Where it's left, and we always read left to right, so why would I, where its left-hand side is the variable w and its right-hand side is 50. The result of this combined expression is, I don't know, do I just simply want to say the outcome is false? I guess. The result of this combined expression is false. Since the remember from our truth table that the only time a logical and is true is when both the LHS and RHS are true. Okay, so I'll read this. So here we have a logical AND operator where the left-hand side is a logical NOT unary operator applied to our X variable. And the right-hand side is a relational binary expression using the less than relational operator, where it's, yeah, geez, it's a little bit too wordy. I'm going to have to fix that. Where its left-hand side is the variable W and its right-hand side is 50. The result of this combined expression is false. Since the left-hand side of the combined expression results to false, the logical AND will result to false. Remember from our truth table that the only time a logical AND is true is when both the left-hand and right-hand sides are true. Yeah, I'm going to come back to that. I'm going to come back to all these, so I'm not going to dwell. Example 3. I might actually change this last one to actually combine another logical operator to make it quite complex. Yeah, I'll do that. Okay, so example 3. Example 3, what do we got going on here? What's that? Sorry, Sammy, did I make a mistake here? True and true is true, false and false is false, all others. Oh, you're talking about the logical and truth table. You got it, dude. You got it. Okay, so example 3, y is not equal to 0 or true. This example uses, yeah, I get it. I'm with you, Sammy. This example uses the, what do I want to say? I don't want to get too wordy. It's kind of like this example results to true. Actually, this combined expression short circuits since the left-hand side is true. Since the left-hand side, semicolon, since the left-hand side y is not equal to 0 is true, when working with a logical OR operator, if the first evaluation, which is the left-hand side, when working with the logical OR operator, if the first evaluation, which is the left-hand side, evaluates to true, C++ won't even look at the right-hand side expression, and it will immediately return turd. Okay. We didn't cover short circuiting in logical. We didn't cover the concepts of short circuiting using logical operators, but here is how it works. When we have a logical OR, recall that either side of the expression, if true, recall, yeah, this sucks. When we have a logical OR, recall that if either side of the expression is true, Hey, no problem there, Sammy. Yeah, you know what? I know this sucks for some people watching me do slides. It sucks. But if you're really new to C++, it's probably good because you kind of get to hear me kind of regurge out ideas, and you probably actually learn from that more than just somebody preaching at you with already prepared slides. I mean, I get that I probably sound a bit ridiculous, and you probably think I probably sound like less of a person, a teacher, than some of those people who are on Pluralsight or Udemy. But you got to take into account that they prep all their work. And I actually know some of those people in a way, like Kate Gregory. I respect her to death. She's, I met her at a Microsoft conference back probably in 03, 04. And she's a really smart woman. And she was working for Microsoft as the Eastern Canadian evangelist program manager for C++. I can't remember her exact title. It was something like that. And she was there presenting a bunch of C++ stuff. And, you know, you get to see somebody presenting material that's given to them. And I actually created 3 of those courses for Microsoft that they give these evangelists. Anyway, she came off, you know, really good, but, you know, you get to see the limitation when somebody is doing it live, even though it's prepared for them and they probably rehearsed it. You're getting to see somebody here who's completely unrehearsed, hashing out how to make myself look good when I'm doing a training course. So, yeah, once all these slides are done, and they should have been done a week or 2 ago, but once they're done, then I'm going to go and present these, and I'll do it for free on Twitch. I'll do the whole course for free on Twitch. I'm going to probably sell it on Udemy for whoever wants to go to Udemy. And, you know, it'll sound like it's completely polished, and you'll think like, oh, that guy's just a genius. And this is just how it is. This is just kind of the creative process for doing these courses. I've been training since I did 3 roadshow presentations for Microsoft in 03, 04. It was .NET, C# on all 3, I think, using different themes, like different areas of C#. And then I taught at my local university for 3 or 4 years, evenings and weekends while I was working during the day. And then I've taught for some other companies. But yeah, it's a lot more polished when I'm teaching something I've already done. Here it's kind of goofballed. But yeah, like I said, I mean, you get to see somebody in the flow of it. So you did VB before the .NET framework. Yeah, I get it. Yeah, it was big, right? Visual Basic was huge. I remember like, I think I started programming right when Visual Basic 6 was out. So probably 98, 99. And I was still a freshman at university. But that's when that came out. And yeah, you know, I dabbled in Visual Basic as well. It was the big language back in the late 90s. It was either everything was kind of Windows based back then. Now it's a lot more, Linux is more accepted in the enterprise. So you find a lot of different languages. But yeah, back in the 90s and early 2000s, it was all Microsoft. I shouldn't say that, but it was big. Yeah, you started the same time. There you go, man. Cool, cool, cool. So, okay, so I got to get this. So we didn't cover the concept of short circuiting using logical operators, but here's how it works. When we have a logical OR, recall that if either side of the expression is true, recall the truth table that when either side of the expression is true, then when either or both sides of the expression is true, then the result is always true. How short circuiting works. Thanks. Or maybe that's just because whatever. How short circuiting works is, what was I trying to, I've just lost my train of thought. Shit. When we have a logical OR, recall the truth table. When either or both sides, when either or both sides of the expression is true, then the result is always true. How short circuiting works is if the first side that gets evaluated is true, then there is no need to evaluate the other side of the expression. And I want to say the first side being the left-hand side works is if the first side, which is the left-hand side, evaluates to true, then there is no need to evaluate the other side of the expression. And that true is the result. There's no need to evaluate the other side of the expression. And a true result is immediately returned. I evaluate the whole thing like a dummy. What do you got? Let me read your thing. I never thought. Let me just see here. I can't see the chat. Hold on. Okay. I never thought of that way, Lafalel. Logical or, if you start off as a true, then you auto. You know, true, there's no need to waste your time. That's exactly how short circuiting works. And it also, I'm just about to type in how it works with and. When we have, and it's important to note, and I won't go into this yet because I probably won't go into it. It'll just be inferred as the course goes on. But some people create these expressions. These are actually pretty easy expressions. Some people create them where there's a function call that, or they might increment a value. Like earlier in this course, where's our W? Here's, let's assume, let me just write this out. So let's assume we've got true or W is less than 10. Okay, so let's assume this expression. So yeah, like immediately this true is evaluated. The left, we always read left to right, unless we use parentheses or unless there's a precedence involved, but there's no precedence here. We know we have a binary expression where we have a left and a right-hand side. So we read the left-hand side first. It's true. So we short circuit, but let's say you can have on your right-hand side, you can actually perform an operation against W where we're doing this prefix increment operator, which would actually really would change W from its default or its stored value of 10, and this would increment it to 11. However, you have to know, like sometimes programmers do this. We get fancy and we're just down with it. You get so intimate with your code that you know that an expression like this, you can save time by incrementing the W here instead of incrementing it on another line of code. So some people do this. It's completely valid. And this would increment W and then check the less than or equal to. Now, we never get to this. And on the next line of code, you might think, well, W is one higher than whatever it was stored. Well, no, because this short-circuited, and you as a programmer may have thought you were going to increment W, and you didn't get a chance. So sometimes people get even fancier when you combine expressions, and they actually do operations in the expression. Yeah, so you got to be careful. You got to be careful. You got to know what you're doing, and it just takes time and experience, right? Yeah, people do that sometimes, and that's why, like, people are on the stream and they're like, well, you're writing an if statement with curly braces and you're only doing one line of code in the if statement. Why not exclude the curly braces? We're going to talk about that in our if. I'm kind of ahead of the game. Here's an example. Like, here's a logical expression in an if statement. If that evaluates to true, we'll perform statement 1, statement 2, and so on. If you just have one statement to perform and you don't put the curly braces on your if, it'll always use that first line of code it sees as part of the if statement. And then if statement 2 is actually inline code that gets evaluated no matter what. So if you forget the curly braces, then the way of how this first example performs, evaluating 1 and 2 only if the if is true, you may have thought, well, this will do the same thing. Well, no, without the curly braces, you only do statement 1. Statement 2 is in line, which will occur no matter what after this statement 1 occurs. So what I'm getting at is, you should be explicit about your code. Even though you did want statement 2 to perform on its own no matter what, you should still probably put the curly braces in there because it's more readable and you're not sneaking in those insidious bugs. And it may seem, okay, what's going on here? Okay, hold on. There we go. You want to be explicit with your code and not do what I was doing here. You don't want to do that goofy increment inside of an expression. You just don't, because you'll think it's all cool and it looks funky. But then, a year later you come back to your code and you're making some code changes and that part is still fine. Then you come back 2 years later and you start adding more to it, and then you kind of F up how that evaluation worked, and no longer your little funky, I feel smart by doing it the short-circuiting shortcut way, and it bites you in the ass. It just does. I mean, I don't have an example of it. I'm just saying, don't do crazy stuff. You can, but be prepared. Anyway, when we have a logical and, short circuiting also comes into play, except this time if our right-hand side evaluates to false, then there is no need to evaluate the, or sorry, okay, so I want to just read out what I wrote. When we have a logical and, short circuiting also comes into play, except this time if our left-hand side evaluates to false, then there's no need to evaluate the right-hand side, since our truth table states the expression will always be false unless both sides are true. Therefore, C++ will not evaluate the left-hand side. Side using logical to false. Not the great. I'm coming back to this stuff to rework it. So that's example 3. I'm actually going to take a break, guys. I'm going to take a break for probably an hour, hour and a half, and then I will come back. So I'm going to actually stop the stream. Please follow so you get notifications if you want to learn more programming. We're doing everything. We did Node.js for the last couple of days. We did C++. We did some games from scratch using C++. We're going to do Mongo game using C# next. But I want to get this training course done. So anyway, I'm stopping the stream. I'll be back in approximately an hour and a half. Talk to you. Thanks, guys.